Monte Carlo simulation. So the basis of this Monte Carlo simulation is the experimentation on the probabilistic element through the random sampling. This technique is defined as a technique for selecting the numbers randomly from a probability distribution to be used in the trial of a simulation model. In this process, the values for the random variable are generated by sampling from the probability distribution. So basically, there are 5 steps in conducting this Monte Carlo simulation. The first one, you have to establish a probability distribution for the important input variables. Then second step is to build the cumulative probability distribution. And third step is to establish the random number intervals for each variables. Next, you have to generate the random numbers. And finally, you have to simulate the series of trials. So when we say random numbers, so in simulation modeling, random numbers are generated by the mathematical process instead of a physical process. And these random numbers are typically generated on the computer using a numerical technique, and therefore they are not true random numbers. And by saying that, it means that they are uniformly distributed, and the numerical technique to generate these random numbers must be efficient, and the sequence of random numbers should reflect no pattern. Now let's look at this example, okay, about the Harry's auto tire. So the store is open 200 days per year, and we want to simulate the daily demand for a number of days. So the first step is to establish the probability distribution. Okay, so this is based on our historical outcomes, and basically this is normally based on the judgment and experience. And by using it, we can calculate the probability of occurrence or the probability distribution for this variable. So for this example, in this example, we have the demand for tires, and we also have the frequency that it happened during the 200 days. And from this information, we can calculate the probability of occurrence or the probability distribution. Okay, so how to get this probability is just taking the frequency, okay, and then divided by the total number of days. So for the step 2, you need to calculate or come up with the cumulative probability. So this is done by just accumulate the probability that we have obtained previously. So basically, when the daily demand is 0, so the probability is 0.05. Then when the daily demand is 1, so you just have to take the 0.05 plus with 0.1, so we have the cumulative is 0.15. So you have to process this information, okay, repeat this calculation until we reach the total probability 1. Then step 3 is to set up the interval for the random numbers. So how to set up this is basically just focus or just follow the cumulative probability that we have obtained earlier. So basically, so for the first one, when the cumulative probability is 0.05, so for the interval for the random numbers, so the interval would start from 1 until 5. Now, when the cumulative probability is 0.15, now the interval for the random numbers will start from 6 until 15. So basically, we just follow the value from this cumulative probability. So next step is to generate the random numbers. But basically, in class or in exam, these random numbers will be given to you, so you don't have to worry about it. So basically, we will just give you a table, a random number table, And you have to use that table in order to answer or to simulate the experiment. And this is the example of a random number table that you are going to use. Finally, we can simulate this experiment. So in this example, you have to simulate the demand, okay, for 10 days, okay, 10 days demand for this shop. So basically, you have to list down from day 1 until day 10, and starting from day 1, you will use the random number from, okay, from the random number. So by just looking at this random number table, for example, the first random number is 52. So if you go back to our table, okay, so this is our table with the random number intervals. So 52 is basically somewhere around here, okay, somewhere between 36 to 65. So in this case, generally we can say that the daily demand for that particular day is 3. And we will repeat this process until day 10, okay, because you are asked to simulate for 10 days. Okay, now after 10 days, we can get the total demand, okay, for these 10 days. So in this case, it is 39, okay, and if let's say we want to find the average daily demand, so basically we just have to take the 39 and then divide it by 10. Why 10? Because we simulate for 10 days. So 39 divided by 10, we have 3.9 average. And from this simulation, please take note that the average demand that we get earlier, which is 3.9, is actually different from this expected daily demand. So basically, if let's say, because we already have the probability distribution table, so by using that information, we can also calculate the expected value or the expected daily demand. Okay, so by calculating the expected daily demand, we will get the value of 2.95, which is different to the one that we simulate earlier. Okay, so the reason for this is because we only simulate for 10 days. Of course, the result won't be accurate because it depends on how many days that we simulate, and also depends on the random number that we use. If let's say we use a different set of random number, so obviously we will get a different answer or different result. Okay, so basically the value of 3.9 is not accurate. Okay, so the one with 2.95, this one is more accurate. And we can also see that the simulation result, okay, that we get will not be accurate like the analytical result, okay, like the one that we calculate here for the expected daily demand, okay, unless we do the simulation thousands times, okay, until it reach the steady state condition.